So today's subject are metals. Metals have different properties than mineral materials. Metals have a certain range where they behave in elasticity, and then there comes a range which is plastic before they break. So we will see how this is used in the creation of metal pieces in construction. There are lightweight metals and heavyweight metals. Lightweight metals below 5 grams per centimeter cube, and heavyweight metals, heavy metal, above 5 grams per cubic centimeter. And the heavy metals are steel, cast iron, and copper brass. You have alloys, combinations of different materials, and we will see how all of these are used in construction. Metal normally resists quite well to tension. An exception would be lead, or another exception would be cast iron, but steel or stainless resist to tension very well. So if you want to create a cable, you would make it out of steel and not out of stone. Well, that seems evident, but it's a property of metal. Metal is, as we have seen, heavier than most mineral materials, and before it breaks, it's just tension on one side, elongation on one side, and tension on the other, and then you have a certain area where metal behaves in an elastic way, which means you bend it and then it comes back to its initial form. And then you have an area of plastic deformation where it does not go back to its original form. And then it breaks, and the cable simply breaks, and people are falling in the river. This particular behavior is quite useful because in special machines we could bend the metal. So we would stress it above this level, but not as far as that rupture occurs. And then we can bend a sheet metal and give it a new form by, for example, a matrix. And this is used very frequently, either in sheet metal bending or also in casting processes. Metal is not combustible, but it has a melting point. And before the melting point is reached, it has a softening point. So you can imagine that for steel construction, if it gets soft, that's not what we want. So if we protect metal against softening, this is made by protective layers made, for example, out of gypsum, or in the earlier day, asbestos-based materials. And this is to prevent that the metal reaches its softening point. Steel is made out of iron, and you extract carbon below 5%, and then the iron becomes steel. So steel is much more elastic than iron is. Iron might be more resistant against rust or corrosion. So each metal has its particular uses. Steel compared to aluminum has a higher softening point. And well, this means that if I want to produce steel profiles, like the double T section, for example, this would be done by rolling the steel. So it's sort of block at the beginning, and then I would transject this through a series of which have a certain profile, like for example something like this, and at the end I would get a profile like this. So this is hot rolling. And what I've been explaining to you before is that you can bend these elements, like for example sheet metal, which has been produced by hot rolling, by cold deformation. So cold deformation is attaining the limit of plastic deformation of the material, and then it stays in its new form. And the basic material is normally produced by hot rolling. Aluminum, which is a lightweight metal, has a lower softening point, which is around 400, 450 degrees. And what I can have is a sort of matrix. And if I want to create a profile, I can cut it out of the matrix, and then I will heat up a block of hot aluminum and with a piston extrude it through the matrix, and then it coldens and becomes a profile which has this specific form. So the hot deformation of steel by rolling produces more rounded sections, and this matrix extruding of aluminum produces very sharp cut and precise profiles. The profiles can be rust protected after, or corrosion protected after coming out of this process. Aluminum would be protected by anodizing it, and steel can be protected in different ways. I could use stainless steel, which is an alloy with chrome and nickel. I could add a protective layer as well, zinc coating. So this zinc coating process is possible because the melting temperature of the zinc is lower than the one of the steel. So I can dip the steel into hot zinc, and then it would rest on the surface of the steel and create a protective layer. Both of them could be painted. I could apply a paint that melts when it is heated up a little. Or I could use a simple lacquer. So all this is coating of the metal materials. We will see some examples later on. So the most common steel sections are the double T profile. It can have a different form with sharper angles or angles that are not so sharp. Then we could have angles, or we could have T-sections. These are normally smaller size, and these are bigger size. We have tubes as well. The tubes can be rectangular or square or round. And what else do we have? We have rods and bars. But these sections are normally smaller, up to I would say 10 centimeters, and this can be several meters high in the extreme cases. These profiles, which are very efficient because the matter is in areas where it can work in a very efficient way, could be created by welding together sheet metal plates as well. This is mostly used for bigger profiles. Then to assemble these sections, you need connectors, like for example, to connect double T sections to a column. I could drill holes in the section and take a little angle, and then drill holes in the angle, and here I would have another double T section for the column, and well, then I could fit it in the column and connect it with the angle. In fact, we are surrounded by metals. Like, for example, this rail here is a steel section. You can see that it's angular on the side, and it has been sandblasted. So at the interior that is possible, at the exterior we wouldn't do that because it would start to rust. The doorknob of the chair here is stainless, as it is touched all the time, so we wouldn't use anything else because it ages quite well. So here on the corridor we have fire protection doors. You can see that they are separated in two parts, divided by this insulating material on the inside. So one side can be exposed to fire and the other sides stay at a temperature which is bearable for people who would come on the other side. So you see it's coated with gray silver paint, and I think it's a steel profile because it doesn't have a lot of little rails and stuff, and it has slightly rounded angles. So this fire extinguisher box here seems to be sheet metal as well. It's made out of steel. This means sealed, and you can see that the fire hose here is on a sort of rim, which is made out of steel as well, and the locking mechanism here is pure metal as well. So all this is rather fire safe here. Our presentation boxes are steel angles here, welded together and then painted white. And you can see that there's a simple glazing to protect the models. Simple glazing is enough because we are in an inside space. So elevators are typical steel constructions as well. You can see that there's stainless sheet metal used for the door, and it has a sort of structure as to avoid that grease would create stains that would be improper in daily use. Handrails of staircases are typical steel construction. So this is a steel tube. You can see that the span is rather big here, 2 meters, and this moves a little as well. It's made out of steel slabs and then welded together and assembled here, screws at these points. So another little shitty steel pavilion. These are tubes. They descend the rainwater in these tubes, and once again the plates, mounting plates, and double T section for the beam, I-beam in the lateral direction. So what you would normally do in this case for rust protection is a zinc coat and a lacquer. And I think here they have left away the zinc coat. So this handrail, which is not so old, starts to corrode already. You can see it on this ventilation shaft behind me as well. It has been rust protected with a layer of paint, and it starts to rust. The end here seems to be a better material than this little sill, because the sill is zinc plated steel sheet metal, and you can see that the zinc coat has been corroding away, so this thing is rusting freely. And this is maybe stainless, so it stays just as it is. So in comparison to this little zinc coated bridge, you can see that corrosion can be avoided. So this is a little pathway through TUM. You can see that there's a handrail. made out of stainless. Here we have zinc coated steel profiles. They start to rust already. And here we have an aluminum facade siding. And behind me you can see walkways composed out of double T I-beam sections and tubes that are zinc coated to rust protect the profiles. You can see that you can make bracing out of steel tubes here and plates that you weld in the tubes. Behind me there are some not very elegant steel construction details, but they show you the process of welding connection plates, drilling holes in them and connecting them with screws. So in Germany or in Europe in general, you would try to weld at the workshop and then assemble with screws on the construction site. So if you weld on the construction site, it's rather difficult to protect the welding spots. So here this has been done with silver paint, but it's less efficient than zinc coating in the hot zinc bath, as I have been recommending before. So the possibilities of steel construction are mostly to create rather lightweight and filigrane structures, as the staircase above me. Another ugly detail here, but you can see that these steel cables have to be tensioned as to be rigid. So this is the tensioning device here. So you can see that I'm not taller than 3 meters 40 and must have been made for me or maybe for lorries that otherwise would be hurting the balcony behind me.